Hi everyone, in this video we're going to look at division with whole numbers. We will look at division with decimals in a video. So we're going to look at the written method for division. It may be that you can do this some mentally. If you can, brilliant. We're going to focus on developing our written methods. So the written method that we use, that is commonly used in mathematics, is called the bus stop. So we are going to divide 4 by 48. So we set our sum up to look something like this. What we are dividing by 4, goes outside the bus stop, and what we are dividing 48 goes inside. So we are going to take the number 48 and split it up into equal groups of 4. Now, the thought process that we need to go through in our minds is how many 4's go into 4 to start off with. So how many 4's can I fit into this number 4? The answer is 1. But we need to remember that is not 1 unit, that is 1 in the tens column, because this 4 was represented by 40. So what we're really thinking about is how many 4's go into 40? 10, which is a 1 in my tens column. And how many 4's go into 8? The answer to that is 2. So 48 divided by 4 is 12. So that's the bus stop method. We're going to look at a couple of different examples throughout this video to help you. So moving on then, we've got a 3-digit number now, 366 divided by 6. Our thought process is no different. We set up what we are dividing by outside the bus stop, and we place what we are dividing inside. 366 divided by 6, or how many lots of 6 can I fit into 366? Now, when I look at my first up here, how many 6's can I fit into the number 3 as a whole? I can't fit 6 as a whole into 3. Therefore, we cross the 3 out and we carry it over onto the next digit. Now, I think how many 6's go into 36? How many 6's go into 36? Our answer is 6. And I've dealt with that 36, so I'm going to cross it out. Then how many 6's go into 6? The answer is 1. So the answer here is 61. Now moving on to something a little bit different, where we are dividing by a 2-digit number. However, our method remains exactly the same. We just need to be comfortable when working with our 24 times table. So, same thought process as before. How many 24's go into the number 2? That can't happen as a whole, so I cross the 2 out and I carry it over onto 28. Now 24 can fit into 28 as a whole. If I list my 24 times table here, the first number is 24, then 48, then 72, then 96, and so on. So 24 fits into 28 once as a whole, because I can do 1 times 24 to get me to 24. However, if I did 2 times 24, that gives me to 48. 48 is a larger number than 28, so we can never go bigger. 24 goes into 28 once with a 4 remainder, so we carry the 4 that we have left over onto the next number. Now, how many 24's in 48? I know the answer to that is 2. Then how many 24's are in 0? There are no 24's in the number 0. Therefore, my answer is 120. And on to our final example, we're doing 321 divided by 5. So set it up in my bus stop. 321 divided by 5. Now, 5 does not go into 3, so I cross the 3 out and carry it over. How many times does 5 go into 32? Well, as a quick coping strategy, if you don't know your 5 times table, you can jot it out quickly. And you notice that 6 lots of 5 gets me to 30. 7 lots of 5 gets me to 35. So I can never go to 35. I can't go bigger than the number I need. I needed to get to 32, so the answer is 6. So 6 whole ones with 2 left over. Now I consider how many 5s go into 21. So again, I use my times table, and I see there is 4 with 1 left over. However, this time, I've got 4, and I've got 1 remainder with nowhere to put it. Now, the strategy that we're going to use here is a little bit of a trick, if you like. So we started off with the number 321. We can write 321 in a slightly different way. So we can write it as 321.0. We haven't added anything to this number. We haven't taken anything away from this number. It is equivalent. It is exactly the same as what we started. It just looks slightly different. We've put a decimal point and a 0 after the decimal point. However, this helps it with this method. So we put a decimal point in and then a 0. Because what I have now is I have a place where my remainder 1 can go. So 5 went into 21's 4 times, remainder 1. Then how many times does 5 go into 10? Twice. So there's an example there when we have a remainder. So 321 divided by 5 is 64.2.